Hi everyone, it's Nono Martínez Alonso here, and this is a live stream on creative AI and coding. For those of you who are new, I'll say this is a channel where we take a look at algorithms and try to learn how to use them, and also see how to apply them for creative uses. I'm also the host of the Getting Simple podcast, where we talk about technology, creativity, and culture. And we're going to get started right on. I will only remind you that if you want to get notified when I go live next or when I upload new videos, make sure to subscribe and click on the bell. All right, and I will also invite you to the community at nono.ma /Discord. You can join the Discord server and talk to other minds alike yours. A recap on last week. So we, well, not last week, actually a few days ago, live stream 108. I took a brief look at the streaming workflow. These are topics that I'm building upon. You have the chapters there for a detail. We also looked at the new MacBook Pro machine I have and took a look at the GPU and CPU usage with OBS. We saw how to add some masks to OBS, as you can see there. And I showed a bit of my marker workflow for the streaming. And I also did a really quick demo of the Dino runtime. These are topics I want to build some tutorials of. And if you're enjoying, make sure to like this video to let me know and let other people know that I should continue making more of these videos. All right. So what are we gonna take a look at today? We're gonna do some housekeeping first, and then we'll look at Apple MLX framework. That's the title of the video, and that's what I want to start introducing today. I have to say, I just briefly touched it before, but I haven't really done anything real with it. I see there is a big push from Apple to provide their own ML framework that can work with Apple Silicon chips. And I want to bring you with me on my trip to actually getting started with it, like the first steps. And the idea is that instead of looking at TensorFlow and PyTorch, there's a lot of videos out there and a lot of people that are doing things with them. What about if we take a look at Apple MLX, the framework, from start? So you're going to see my first steps and the things that I do. And then maybe later we can extract some of the knowledge and the takes that we do in separate videos and build a playlist tutorials for those videos, right? There's many topics we're gonna see. So yeah, so before we continue, yeah, and one topic that I haven't covered yet is Llama Index. We did a few tests with running Llama locally on my other machine. I haven't tested on the M3 Max yet, but I suppose it will be faster. And now what we're gonna try to do also is try to do this through MLX. So let me create a new marker here and talk about what we're gonna do today. So some housekeeping before. All right, so this section is just a bit of housekeeping before we jump into Apple MLX, the array framework for Apple Silicon. And I'm gonna show you, so what we did last week. So I'm used to saying last week, but it was actually just a few days ago. So I have this diagram here. We went through this in the live stream, in live stream 108. And I explained a bit the workflow I have set up. I would like to show my studio, the work in progress that I have here, and some of the things when it's a bit more done. I could actually show you guys a sneak peek. If you let me know in the comments you want to see that, I can show a sneak peek of like the setup that I have here right now. And yeah, we're gonna keep seeing things like this. So let's go for a second to my desktop. I have this document here with the content that we're seeing on the live streams before. So as you can see, the start of season 4 has taken some time, but we're now there. We saw the new MacBook, remarkable OBS scenes, and some other things in the previous live stream. Today, the focus is going to be the Apple MLX framework. I wanted to do some of these things. I haven't really done any of that on the live stream yet, and those are some things that I would like to show you, so you get to know a bit more of the things that I'm thinking of doing and sharing here on the stream. This talks about setting up Farrago, which would be some audio effects for the Stream Deck board that I have here, the controller, file organization, something that I'm undergoing. I already have a pretty good structure for some things, but I'm trying to look for a long-lasting structure, because now I have configuration files and files that my computer needs, projects, files that are active, archive projects. Some other things are just like resources. Some other things are just data and admin stuff. And the big files of like podcasts I record and audio I record, which is a bit unsustainable to keep on Dropbox, at least with the plans that they provide. Right now I have 4 terabytes of Dropbox, and that's not enough. And then Descript AI, I also wanted to play a bit with that, but it seems that we start playing with these things, we're gonna get a bit lost today, so I'm probably not gonna do that too much, and we're gonna move on into some of the actual content. So let me actually go and explain really briefly the thing with the the thing with the file organization, Farrago and all other stuff. So today is 22nd of December, and this is live 109. And so we have those 3 things. Farrago is an app where we can set different sounds on sound bars. For example, you could say, okay, this sound is going to play when you press key A on your keyboard. And that would be some sound effect. You can actually connect some of these things also through the Stream Deck. So the Stream Deck has also a set of keys. So you could say, okay, when I press this key here, this is going to play that audio file there. And that's for the sound effects, right? So this would be for something called Farrago. Is a program by Rogue Amoeba. So that's a software development company. I also use Loopback and Audio Hijack from them. And so that would be the first thing. And then for the folder organization, I actually want to have some set of folders that allow me to be more flexible. One of them would be my settings folder, which is basically the things that we actually basically programs need for daily workflows. For example, like assets for the live stream that I use every time I create an asset. So a live stream, files that OBS is loading. For example, this mask here that I built in live 108, that's in that folder. And some other things, I don't know, like Typinator expansions, some other things that we have that if you get a new Mac, or if you want to work in a Mac with like the minimum set of things synchronized from Dropbox, that those things are going to be having to be offline, right? Like downloaded to your computer. There are other things that are going to be like active projects and archive projects. Archive projects you don't even need to download unless you want to reference something. The active folder is the things that we're actually working. So for example, for me right now would be like the live stream, the sketches, the podcast. So certain things that you actually have to have there. Then we'll have some data stuff. And I'm also going to have like a media folder for big files, and that would be in between my folders in Dropbox and some SSD drives that I've got recently, where we probably don't want to have everything on the cloud. And then for the last topic that I had there, so this was the Descript AI. Let's actually take a look at a really brief example there that I can show you, and that will basically give you an idea of what I want to do in the future, not today, but we'll do that in the future. So I'm gonna sign in here really briefly to my Descript account. Somehow it got logged off, and we're gonna see a demo there. Okay, so this is Descript, and for those of you who haven't seen it, it's a transcript-based editor. It's based on AI, and you know, if I go to different parts of Live 108, which is the live stream that we did, I believe on Wednesday, like 2 days ago, you can see the different parts. I mean, this is just a video editor as any other, you could say, but I could actually, if we make a selection here, I could, and actually, yeah, let me see if I can. I'm gonna make a selection here. So let's say here, yeah, this part, let's go. So for example, here, I could select this thing here, this piece of text, and I could click, right click, duplicate to new composition. So that's actually going to shift command C. Let's actually try to do that. Command shift C. Selection added to new composition. We click open, and this is our new composition. So now by selecting a piece of the transcript, we've created a new composition. So that's a new video. And note how it even highlights these filler words. I can really quickly remove those filler words. So we could go here and say remove filler words, and that would be basically remove all. It just deletes them automatically. And so that's, you know, that's AI based because it's basically doing a transcription and it knows. But we could actually ask the AI here. So I've ended demoing a bit this workflow, all filler words, blah blah blah. Okay, so I can go here and say ask AI, and I can write here something like generate or like write a summary of this video for YouTube of like maybe like 20 to 50 words. So AI is thinking, and it actually helps us. Based on the script you provided, the video appears to be a review of a new MacBook Pro M3 Max. It mentions the speaker's positive experience with the machine, and it highlights powerful features such as 16 cores and 64 gigs of RAM. The video also mentions the speaker's plan to use the machine for recording videos, editing, blah, blah, blah. Okay, so now I can say, turn it into the first person. The speaker name is Nono. Hi everyone, today I want to share my experience. Start with, in this video. This video I want to share. I recently got this machine. Turn it into the third person and mention the speaker's name. This video, Nono will share their experience. I recently got this machine and they blah, blah, blah. Yeah, so you can get things like this really quickly with Descript AI. And if we go to the full composition, they actually have some pre-made things here that they allow you to find good clips. What is this? Summarize. yeah, they actually have some sort of pre-made thing. So show notes, draft podcast style show notes for this, and I click here, and I already showed that we have this workflow for creating markers, but here it actually proposes a title: unveiling the MacBook Pro M3 Max A Power Users Insight. The presenter discusses a description, and then we get some markers for the video, right? Yeah, I already have the chapter markers here, so I think it got biased by them, but that's not what it normally does. So it actually proposes more. Let me see. Start over. So we're asking for chapters now. And for those of you who are online, I would really appreciate if you say hi on the chat and let us know where you're connecting from. Or if you're watching later offline, leave a comment on this video. All right, so here it told us introduction and overview, discussing streaming workflows, exploring new tools and equipment, joining the community, unveiling, blah, blah, blah. So there's like a ton of chapters: running Whisper locally, exploring Whisper's transcribing tool, create a map of remarkable sharing screen, exploring Python environment, FFmpeg. So this is pretty good because it's able to extract like when topics change, and you can add to script or add timestamps, right? Let's see, timestamps. Yeah, you see now we have all these timestamps, and we actually can see what we did in this video even more detailed than the markers that I added yesterday to the actual video. Okay, so this is for Descript AI. Let's close this now. Let's call Descript, close Descript, and let's go to Apple MLX. Okay, I'm gonna create a quick intro here. So we're gonna reuse this thing to MLX Apples. So here we have array framework. Array framework for Apple Silicon. All right, so I'm gonna now record an intro for this in case we use it later, but we'll jump right on and actually start coding, creating an environment for MLX and doing some of other things like this. Okay, let's record here an intro. Hi everyone, it's Nono here, and this is an introduction to Apple's MLX framework. This is an array framework for Apple Silicon that Apple has created, completely customized to run on their new software, on their new hardware, basically the Apple Silicon Max. Okay, I'm gonna do another take of this really quickly. Hi everyone, it's Nono here, and this is an intro to MLX, Apple's array framework for Apple Silicon, which is a framework optimized to run on Apple's new hardware. This is like M1, M3, and M2 chips. And yeah, let's dive in. And I'm gonna do one last take of this thing. Hi everyone, it's Nono here, and this is an intro to MLX, an array framework for Apple Silicon that Apple has designed to make the most out of their M1, M2, and M3 chips. Today we're gonna test all of this in an M3 Max computer, but you can use it on any of the M line of chips. And I invite you to take a look at MLX from the very beginning with me, because I have not really used this. Just really briefly tried installing the package, but I haven't really done anything with it. So we're going to see how to set up an environment. We're going to see some of the documentation, some of the samples that are out there that we might or might not have time to use today. And yeah, leave some comments and let me know if you have done anything with MLX on the video, and make sure to subscribe and click on the bell if you're going to get notified when I go live next or when I upload new videos. All right, let's get started and see what MLX is about. Okay, so we're gonna start first Googling MLX, right? So if we Google for MLX framework, we find the MLX repository here on GitHub. Apple describes it as an array framework for Apple Silicon, which is how I described it before, because I saw it here as well. And you have quick start guide, installation instructions, documentation, and examples. These examples part takes you actually to the MLX examples repo. They seem to have created a good fledge of examples that we can take a look at with the latest state-of-the-art machine learning algorithms, transformers, llama, LoRa, low rank adaptation. And this is pretty cool because it also works with like Stable Diffusion image creation, or Whispers OpenAI speech recognition, which is, these are not old algorithms. These are new algorithms, or what people are hyped about and want to be using today, right? So yeah, the first thing we can do here is see like how do we install Apple MLX, right? I assume that you're running Apple Silicon machine, because this framework is done for this. So we don't really need to explain how to install in Windows or Linux. We're just going to see how to install it on Apple Silicon Macs. And in the end, this is a Python framework for us that we can install. And you would install just with pip install MLX. It's pretty simple. We're going to create a Conda environment just for this, so we can have a closed environment where we run our things. And there is also a quick start guide here. So the basics are here. It talks also this tutorial about how to use it quickly, just to do a few things as you would do in NumPy or TensorFlow or PyTorch. Some things about unified memory and using different devices, and how to use streams. And then we have some examples and the Python API reference there. So let's go and create a Python environment for MLX. As I said, I'm gonna just run through these things in a continuum. I'll try to create marker chapters for the videos, but what we will do is that we are going to try to just learn stuff, and then I'll do record videos and tutorials at some other point in the future, right? So let's create a Python environment for MLX. We can open a terminal here, and I'm just going to do Conda, and let's make this a bit bigger for you. Conda, right. Okay, take two. All right, let's see how to create a Python environment to run Apple's MLX framework. I'm just going to do it with Anaconda. So Conda create environment. Here, MLX, we're going to say Python 3.11, and we're going to say yes. This is so Conda just does its thing and doesn't ask us for confirmation when creating this environment. Note that MLX is just on the name of this environment. We can activate with Conda activate MLX, and now we still have to install it. So we'll do just pip install MLX. And before we do that, I'll invite you to do which pip to verify that the pip that we're going to be using is belonging to the MLX environment. So I have this here. I'm going to reset there, and I'm going to say pip install MLX. And after this here, I just get asked if I want to let that Python access the internet. And we have MLX 0.0.6. and that should be already available for us. If we run Python, which again, we can see which one it is, it's going to be the one in the MLX environment. So we just do Python enter, and in this version, we can do import MLX as MX. And that's what Apple normally does. We can see here mx.version, and oh, no attribute version. Maybe just output MX, and we see there is that model there. All right, so we've seen how to create an environment where we can use MLX. Let's now go into the quick start guide in here. Let's put this page in here and take a look at what we can do after we've installed. So we go to the quick start guide, and let's make this a bit bigger. Let's see if we can close this thing. All right. So we have nice instructions here, right? Great. So import MLX core and make an array. Import MLX core as MX AI. All right, so I'm gonna have this code and we're just gonna write it from scratch. So we're gonna go into the live folder, not this one. We're gonna go into my repos, and we're going to make the directory for today's live stream and access it. We'll do here mlx.py, and we'll open that folder in Visual Studio Code. And great. Okay, so this file's empty. I'm gonna do this import MLX core as MX. Is that what they're telling us? Okay, MLX core as MX. That's what we needed to do. Will not be resolved. But I think inside of our Anaconda environment, if I do conda, let's say conda activate MLX, we can run this file, no problem. Oh, no model MLX core. MLX is not a package. Pip install MLX. Already satisfied. What's going on here? I mean, we have MLX, which Python? That's interesting. All right, let's take a look if we did the right install. Pip install MLX. Check documentation, blah, blah, blah. All right, import MLX core. Let's actually try in our Python environment first. Python import MLX as MX. Import MLX core as MX. No model name MLX core. All right, let's take a look here. If we go, which Python? Okay. Okay, let's go here. right? No. Not sure. Lib. Okay, let's go here. Lib Python 311. Okay, library seems to be here. I just don't know why. Conda activate MLX Python, and can we import MLX as MX and then do MX core? That's interesting. Okay, we got a blocker here, and let's see. Okay, they updated, so they released a new version 10 hours ago. So let's take a look at the releases, because okay, let's just try here. So we go into Python, import MLX as MX. Do we have MX? And then no. MX array, no. Import MLX core. Import platform, platform processor. All right. Import MLX core. Import MLX core as MX. Huh. All right, that worked now. I don't know why. What did I do that is different? All right, now it worked. And I'm not sure Not really sure if I did anything to change that. Okay, let's go back. Import MLX core as MX. That's so weird. Okay, I'll go back. I think I'll go back on the video and check if I made any mistakes or if I was doing any typos, because that is so weird. Okay. Great. So let's create a marker here. Let's test then that this works for us as well. Can't really hide this here or what? Okay. Great. All right. Okay, let's actually place this here so I can read and you can read and we can take a look at the example. Okay, so we have here import MLX core as MX. That's what wasn't working, because this is working for us. MLX core Python. Which Python? Okay, and okay, so let's go back here. Let's open a new terminal. We're gonna try repos. Okay, conda activate. Okay, so all right, so let's see how to run some sample code here. Conda activate MLX. We're gonna verify that our Python likes MLX core as MX. No model name MLX core. That is so weird. Why on earth is this failing us? Import, okay. MLX core as MX, import MLX. No model name. Okay, we do Python version, Python model pip install MLX. Okay, upgrade. Okay, Python import MLX core as MX. Huh. But why? Why are you doing this? That is so weird. Okay, let's just try to remove the this environment and create another time. I'm actually going to create it with an older version of Python, just to make sure that's not the problem. So I'm going to do create MLX, and we're going to do Python 3.10, and we're going to do yes. Honestly, I don't really know what's going on, but this happens. Okay, on the activate, this is how you know it's live. On the activate MLX, which Python. I'm gonna do it like this to make sure. Allowed. In please work. Ha. No idea. Okay. What if we do Python pip install MLX? All right, let's try that one. All right, there's something I'm not getting, and I don't know why it worked before, honestly. Why did it work before? Okay, let's see. Our Python default is 311. Python, so pip list. Okay, I might go back into the recording and see what I did differently. Honestly, that's so weird. Okay, list. Okay, let's see. So if this is this, let's do conda create silicon. Let's change the name. Just not put any versions. Okay, conda activate. Now what version of Python we have? Okay, let's try 3.9. And we'll do conda activate silicon, pip install MLX, and write Python import MLX core as a max. What's going on? What is going on here? Okay, I'm gonna, yeah, I mean, that's what's weird, right? We cannot use this in Google Colab because they don't really have Apple Silicon processors. Let's do this. Okay. Ha. My bad. I know what happened. Great. Okay, so let's explain what happened, and I'm sorry for what just happened. This sucks. Okay, I wasted some time there. Let me show you. At least we know what happened. If I'm on my desktop, I create a directory called sample, and I go here. This is empty, but I can create a file called mlx.py, and Python will try to import it when I do import. So that's why when we change directories from to outside where this script is not present, so you'll see that if I do here import MLX core as MX, that's gonna fail. But if I put here app, for instance, this works. And we're gonna actually print here MX. Great, okay. At least we know. Sorry for wasting your time. I'll add chapters there for people who come later to this video. Okay. Great. So give me a really really brief second, and we'll continue with this. Let's go here. All right, we're back from the break. And yeah, so let's see. So I figured out one really simple silly thing that I've done that it's just my own fault, and that's why nobody was looking for that. So we're gonna download, create an environment from scratch again, and we're gonna run MLX 006, and now we will be able to do our first example. Okay. So let's do that. We're gonna repeat the process. So I'm gonna do here a cleanup. So we're gonna remove the silicon environment, and we're gonna create one that is gonna be called MLX again. So let's go here. All right, great. And I'm gonna leave this here for later. Great. Okay, so let's get started again. I'm gonna create another marker here. We're going to create an environment called MLX. Let's see. All right. Hi, everyone. It's Nono. We're going to really quickly see how to create a environment, a Python environment for the Apple MLX framework here with Anaconda. So I'm going to simply do conda create. We're going to name our environment MLX. This is not installing the package. It's just setting the name of the environment. We're going to say Python 11 and we're going to say yes. So conda doesn't ask us for verification. In a few seconds, we're going to have our Python environment. As you can see with conda activate, we can activate that environment. You're going to note that if we do Python and we then run some code here inline, import MLX, that framework is not existing because it's not installed. So what we're going to do is that we're going to run pip install MLX. It's going to grab 0.06. That's the latest release from 10 hours ago as we record this video. And now we're going to run the same command and it's not going to complain. Actually, Apple says for us to do import mlx.core as mx, and that also works. And we could print here. I'm going to try to print this. I don't know if that was available. Yeah, and we get the version. So we have 006 installed here. That's nice. All right, so now we're going to create a sample script and we're going to follow Apple's guide to do a quick start. I'm going to go into my repos and I'm going to open the folder for today. And I'm going to change this MLX script to something else. So we're going to call it silicon.py. Because as we saw in this, while we were recording these videos, is that if you do name your script MLX, before I do this, take a look. Like this code is not going to work anymore because Apple is trying to import MLX from this model here, this Python file. So we're going to rename that. And then when we run this code again, it's going to work. Great. Okay, so we have an environment here that has MLX installed and we're going to follow the quick start guide. I have a silicon.py file, so I'm going to open my folder here and open that silicon script. And we're just going to do here import mlx.core as mx. We're going to verify that our environment doesn't complain, and it doesn't. And we're just going to leave this here so we can continuously run our script. All right, so the first thing that Apple tells us to do is set an array. It's going to be 1, 2, 3, and 4. They do nice spacing, and we can print a shape. We actually, we don't really need to do this here. We can directly do it here on the console. So I can open a session here and I can import MLX core as MX, and we can set our array in here 1, 2, 3, and 4, and we can print it, or we can its shape. D type is uint32, and now we're gonna do a new array with a different type. You can see probably what this is gonna be. I'm gonna skip the 0 here just to try and see what type it gives us. B, D type float. You see it removed the zeros, but it knows it's a float. So we can do B shape and B D type. Great, so we have MLX core float 32, int 32. Okay, operations in, so let's see if I do this. Okay, so we have a nice way to go back and forth. Operations in MLX are lazy. The outputs of MLX operations are not computed until they are needed. To force an array to be evaluated, use eval. Arrays will automatically be evaluated in a few cases. For example, inspecting a scalar with array item, printing an array, or converting an array from array to numpy the array. All automatically evaluate the array. All right. C, A plus B are not evaluated. MX eval C evaluates C. C, A plus B, print C also evaluates C. Array, blah, blah, blah. import numpy and also evaluate C. Okay, so this is just an example of when arrays are actually evaluated. Function and graph transformations. Okay, so let's do this. Okay, so MLX has a standard function transformations like grad and vmap. Transformations can be composed arbitrarily. For example, let's see here. For example, grad vmap, grad fn, or any other composition is allowed. All right, so you can basically compose a nest in there, and we're gonna follow this code sample here. I'm gonna put it at the top. Oh, I can't really scroll anymore, so I'm just gonna put it in here as a little snippet. Okay, x is mx array 0, 0, mx in x array. So if I print x, that's 0. Right, mx grad, mx sin x, mx grad, mx sin x. Oop. Other gradient transformations include VJP for vector Jacobian products and JVP for Jacobian vector products. Use value and grad to efficiently compute both a function's output and gradient with respect to the function's input, value and grad. All right, so we've seen just that we can run these operations, and now we're gonna see where these operations run. Do they run on the CPU? Do they run on the GPU? All right. Okay, so now we're gonna see unified memory in MLX. Do your operations run on the CPU or do they run on the GPU? Apple Silicon has a unified memory architecture. The CPU and GPU have direct access to the same memory pool. MLX is designed to take advantage of that. Concretely, when you make an array in MLX, you don't have to specify its location. You can do A equals this or B equals this. And then when you actually run the operation, you can specify in what device you want it, right? Both the CPU and GPU will perform the same open operation. The operations can and likely will be run in parallel since there are no dependencies. See using stream for more information on the semantics of streams in MLX. In the above example of add, there are no dependencies between operations, so there's no possibility for race conditions. If there are dependencies, the MLX scheduler will automatically manage them. For example, running something on the CPU and then running something on the GPU that depends on the result of that first operation. The second add runs on the GPU, but it depends on the output of the first add, which is run on the CPU. MLX will automatically insert a dependency between the two streams so that the second add only starts executing until the first is complete. A simple example. All right, so I don't think we're gonna see anything at all if we run this on the GPU or the CPU. Like, I don't think the activity monitor is gonna show us anything. But it would be nice if we could actually get some operation that takes our GPU up or our CPU up, right? Let's see how we can arrange this so we can see it a bit better. Let's leave these guys here and the GPU in here. Right. Okay. Okay. Great. So now we have this set up here. A simple example. Here's a more interesting, albeit a slightly contrived example of how unified memory can be helpful. Suppose we have the following computation. So we have this def function AB D1 D2 mag mult. So we're doing a multiplication, stream D1 in range exponential. Okay, so which we want to run with the following arguments. A, B, random uniform shape, blah, blah, blah. Yeah, these starts being bigger because it's like a highly dimensional. The first mad-mul operation is a good fit for the GPU since it's more compute dense. The second sequence of operations are better for the CPU since they're very small and would probably be overhead bound on the GPU. This is better for the CPU, this for the GPU. If we time the computation fully on the GPU, we get 2.8 milliseconds. But if we run the computation with D1 MX GPU and D2 MX CPU, then the time is only about 1.4 milliseconds, about twice as fast. These times were measured on an M1 Max. All right, so that is pretty cool. We're gonna, let's run this on this M3 computer, so we can let's actually hide these guys. This is 4 and 3, or let's see, 4. Okay, it's only show, but they don't hide. Okay, so this is 3 and 4. All right, 3 and 4. Okay, so let's actually get this code from here. Let's just rewrite it. Okay, so def fun a b d1 d2 is gonna return x and b. But what are x and b? So x is mx mat mul, a b stream d1 for I in range 500, b equals m exponential b stream d2. Right. And now, okay, so A equals mx random uniform shape 496, 512, and B equals random uniform shape 512, 4. And I guess we just run here a B, D1 MX GPU, D2 MX GPU for now. And we simply have to Python SiliconPy. Okay, so that works. We'll do here. Okay, so let's say OpenAI, I don't remember right now how to time it. Time the execution of Python code. Okay, import time. Oh, import time. So start time, and then end time. We don't really need this variable, but okay, start time, execution time. Okay, so we'll print here took execution time seconds. Okay. The other way around. Okay. Okay, so milliseconds. Okay, so let's multiply by 1000. All right, so both on the GPU, it's 0.78 seconds, which is 3.5 times faster than M1 in M3. And okay, so let's do this. So D1 equals, can we actually do that? Okay. All right, let's try this out. And so we're gonna run with like CPU the second time, and we'll do CPU for the last one. Okay, so let's run this one more time. Great, so with GPU both 79, with GPU and CPU 76, with CPU and CPU 75. Is this really... It doesn't seem like there is a difference as they're saying, so I'm not sure if I'm missing something here. If we time the computation fully on the GPU, let's run it again. Don't really see a huge difference. Let's actually do what I wanted to do before. Let's actually make this program huge. I'm not sure how big this is, but let's bring up these guys here and let's execute the program. All right, so let it sit for a second. And okay, let's execute. Oh. Okay, so we're gonna leave this here. There you go. All right, so we can see the spikes on CPU, performance CPU. Some of these bars here. It's calculating. Not so much. I mean, CPU, maybe this is the GPU. But, you know, we were seeing GPU spikes every now and then. It would be good to know which part GPU. I'm not sure what it's doing because it, okay, yeah, so it's here, somewhere here. Segmentation fault. No idea what's happened. Okay, let's make it a bit smaller, not so big. That's his CPU, right? Okay, that's what we've increased. It's a bit more CPU. Let's try to pump the GPU. Okay, great. Well, so we've seen some introductory code to MLX. So now we know how to create an environment, how to run some of the sample code, and what we'll have to look at next is, so what we will have to look at next is Apple MLX samples. So you can actually go to the repo specific for that. So at github.com/mlexplore MLX samples. And, you know, they have pretty good examples. So maybe one thing, if you converted checkpoints from the MLX community, this is pretty cool. This is pretty nice. Let's take a look at the MLX community here. Mistral, Tiny Llama. Okay, this is exciting. So this is what we're gonna play with. Speech recognition, Stable Diffusion. Let's see if we can run an example, Stable Diffusion. Let's actually clone this repo in our desktop. Actually, I keep making my typeface bigger. I'm gonna try to see if I can make that a default template or something for the live stream. We have this one. Let's duplicate that for let's make it bigger. Let's do 40. What is that? Oh, 45. 40 is good. How does that read? Let's try, yeah, let's try 40 or 38. Let's try 38. No, Excel. Let's try. All right, let's try this one. Right, so we can now create windows this way. It's a bit bigger, so you can read it better. All right, let's try to run some of the MLX examples. We have the repo here, and we're gonna copy and clone it to our desktop. So git clone that MLX examples, and let's open the Visual Studio Code. So I want to try the Stable Diffusion demo. Stable Diffusion, text to image, README. Okay, let's actually go to the README on the repo. Would be better. Stable Diffusion in MLX. The implementation was ported from Hugging Face Diffuser and we're fetching and using the weights available on the Hugging Face hub by Stability AI, Stable Diffusion 2.1. Image generating system, blah, blah, a big red sign saying MLX in capital letters. Okay. Dependencies are minimal, namely safe tensors, Hugging Face Hug, regex, NumPy, TQDM, pill, text to image. Okay, so let's install. Okay. And yeah, hi to those of you who are connecting with us live. I see Rogan Gupta. Where are you connecting from today? I'm really excited to have you. We're taking a look at Apple's MLX framework for Apple Silicon. Okay, so here what we're gonna do first is go to the Stable Diffusion directory, and what I'm gonna do next is you can see here the requirements file, and these are basically the dependencies. So we're just gonna run pip install our requirements, and this will install the files or the dependencies of the Stable Diffusion example from MLX. Hi, Rohan from India. I'm excited to have you. How did you found us? Are you learning machine learning? Is this something that you're interested in? Okay, so now that we have this, let's keep on reading. So usage, although each component in this repository can be used by itself, the fastest way, let's put this here, the fastest way to get started is by using the Stable Diffusion class from the Stable Diffusion model. From Stable Diffusion, import Stable Diffusion. This will download all the weights. This creates a Python generator, returns the latent produced by the reverse diffusion process. Because MLX is lazily evaluated, iterating over this generator doesn't actually perform the computation until mxeval is called. Latent generator, generate latents. Photo of an astronaut riding a horse on Mars. Here we're evaluating each diffusion step, but we could also evaluate once at the end. Now xt is latent from the reverse process. We can decode into an image using blah, blah, blah. There will be almost line for line implementation of tx2x image. You can use the script as follows: Python text to image. All right. So let's try Python stable. Nope. Okay. Python text to image. A sunflower field, blue sky, green mountains, clouds by Edward Hopper, and images 2. Right, so this is now running. Let's actually, well, it's downloading the models. Let's actually run our GPU and CPU panels here just to see whether this is gonna make high usage of the any of those components. It's at the same time downloading the model, which is 3.46 gigs, and you know that's gonna take some time. We're over Wi-Fi here, and will take a bit, but not too long, it seems. Let's, in the meanwhile, open the source code that Apple has created for us. Oh, take a look at that. That was some efficiency course there to open Visual Studio. Okay, so we do have here text to image. This is the code that we just saw from Apple. Still downloading. Okay. So yeah, so this is the code here. Generate images from a textual. So we have steps and images, CFG. It's kind of like basis. Generate the latent vectors using diffusion, latents, SD generate latents. Arrange them on a grid. Right. And here I can see a live comment from Rohan Gupta. I'm currently working as a junior AI engineer in a startup. I'm very new to this field. Could you suggest me some tech to get better in AI ML? Well, here we're looking at Apple MLX, at the framework that Apple has recently released, analog to PyTorch or TensorFlow to work with arrays, and is specific to work with Apple Silicon Max. That means hardware that Apple has designed with the latest ARM chips, and this won't work in other computers, but I'm sure that at some point there will be some sort of compatibility. But I mean, at the end of the day, they're trying to do the same things that other people are doing, but in a more efficient way on Macs, because in this way they use the unified memory architecture in their chips better. Some tech to get better in AI. I mean, I guess this is something you could ask on Discord. So if you go to the Discord community, maybe we can have that question there and answer offline. It's a pretty wide question, like what tools to use. So you can join the community at nono.mas/discord. It's a pretty wide question, right? Like to basically get better in AI ML. We have some or many videos here on the channel, so I would recommend you to subscribe and follow, because we're going to be doing a lot of this in the channel. And you can subscribe and click on the bell to get notified when I go live next or upload new videos. And yeah, I have like tons of live streams with different things, but I need to know a bit more also. If you're an AI engineer, does it mean that you're releasing models to the cloud that you want to deploy, that you want to learn how to modify existing models, or that you want to write models from scratch? There's like different levels of AI and ML that you can do. Okay, let's get here really quickly. This is running, so let's see where our spikes are. Great. Okay, so this is exciting. This is the first time I've seen like the 64 gigs of RAM, it seems, from the Apple M3 Max are running. So we've topped here, and we also have some sort of spike from can we make this bigger? Some sort of spike from the CPU as well, and we've generated the two first images with Stable Diffusion on an Apple Silicon Max with MLX. Apple has made it super easy, as you can see here, so we can actually, I mean, they make them into a grid here. We don't really need to do that, but they do that as a nice image from array. They save it. We could also save each image independently, so we could easily change the code. So let's actually generate more images with the same prompt. Now we can do, for example, let's say 12 images, but we're going to change that the steps is only 10, so they're going to be a bit crappier, let's say. But let's see that spike on GPU there, how it plays out. Let's make this bigger. Let's see when it generates. Now okay, so my computer froze for a bit there when it's loading the model or when it's doing some stuff. I actually can see that my the camera is freezing a bit. I'm not sure what's going on. It's probably just loading the model. Yeah, probably was loading the model, but it's been using the GPU a lot and probably also some CPU. Okay, not sure if this is generating one image on or if it's running the 12 of them in parallel. That I don't really know. Let's see. Seems pretty slow to be making just one image to me. Okay, we need to learn more about this process, because if that is to generate 12 images, that's pretty crazy. Wow, okay. That's pretty neat. I mean, that was pretty fast to make 12 images. Hmm. It's nice. So let's see if I just want to make one image. Does it take the same time? Okay, 1 second. I'm gonna take a look at something here while this generates. All right, so it seems I'm seeing here we've missed some frames on the stream because of rendering and encoding lag. So that means, I'm using Stable Diffusion there, and that's making the computer use a lot of resources. One thing we could do is try to see how much during the live streams, if we can limit the algorithms to not use the entire GPU, because that's basically, I mean, we're generating images with ML here, and that actually makes my computer slower. So why not? I mean, I could also hide myself and you wouldn't see me like lagging or anything. It's just the computer doing its own thing. Okay, I'm sure we can play out and do a lot of things with this algorithm. I wanna understand a bit, and this I'll spend more time, but they arrange the images on a grid, they code them into images. We need to see how much each part actually takes. Generate the latent vectors in diffusion. Okay, I'm gonna spend some time looking at this and I'll report back. But I mean, this is pretty cool that we can make use of Stable Diffusion here, and there's also Whisper AI and other things that we can do. So thanks a lot for joining. I might do another live stream later today. This was let's see where this is. This was a first approach to MLX. So thanks a lot for watching. This was Nono Martínez Alonso. We took a look at MLX, an array framework for Apple Silicon that Apple has recently released. I will remind you that you should subscribe and subscribe and click on the bell if you want to get notified when I go live next or when I upload new videos. Thanks so much for being there. Welcome, Rohan, to the stream. And yeah, so here Gupta says one last thing, says, yes, you're right that I'm releasing models and working on CV and LP, but I want to get better understanding the model underlying architectures. So how should I proceed? Well, I would recommend you can actually browse through past live streams. We have 100 live streams, and many of them we actually go through and write or rewrite some of the examples from scratch. So you can actually go to nono.ma/playlist/live, and that will take you to this playlist where we've covered a ton of things that you can see here. We've covered a ton of things, like from using algorithms to like looking at algorithms from scratch. Let me see if I can open some of them that actually do machine learning from completely from scratch or training some other algorithms. So for example, the stacked autoencoder series was one. I'll mute myself in these videos, but yeah. So here, for example, we actually get and start writing code and learn how to use some of these algorithms from scratch and trying to understand what each part is doing and all the things. So yeah, there's a lot there. Let's see if this one actually also linear regression. Yeah, it's a lot of stuff there. Yeah, nice to meet you, Rohan. Thanks for being there online, and we'll see you in the Discord community. All right, for everyone, it was Nono Martínez Alonso here. Thanks so much for watching. I'll see you on the next live stream, which might be pretty soon. And yeah, have a nice day, and keep sharing stuff on Discord or leave some comments on the chat if you have any questions or any comments. Bye bye.